In this video, we're going to find the x-intercepts, axis of symmetry, and vertex of a quadratic function that is written in intercept form. And remember, our intercept form is when we have y is equal to a x plus p x plus q. So that's the form we're going to be looking at, and we're going to identify x-intercepts, axis of symmetry, and vertex. So in the previous video, we talked about intercept form and how intercept form through its values of p and q actually supplies us with our x-intercepts. So here we can see that p is equal to 4 and q is equal to 2. And our x-intercepts happen to be the opposite of p and q. So our x-intercepts we can see are -4, 0 and -2, 0. So intercept form supplies us with our x-intercepts immediately from the equation. So now if we start to picture what this might look like, we can see that we're going to have an x-intercept at -2 and -4. And we know that due to symmetry, that our axis of symmetry and our vertex actually lie in the middle of our intercepts because we have a symmetrical graph. So there are two ways to find your axis of symmetry. You can either find your axis of symmetry by looking directly at the graph and saying, well, here's -4 and -2, and the middle number here is x is equal to -3. That is one option that you can use to help you find your axis of symmetry. The other thing you can do is you can find the average of your two intercepts. So if it's not so obvious to you, find the average, and you just find the average by adding them together and dividing them by 2. So we take -4 plus -2, which becomes -6 divided by 2, and we get that same answer. So our axis of symmetry here is x is equal to -3. And then from here we know that our vertex point lies on our axis of symmetry. So here we can then find our vertex and say, well, we know that the x-coordinate of our vertex is from our axis of symmetry, so we simply need to find our corresponding y-coordinate. So here's where we use our equation. So we say y is equal to 2. We substitute in our x value of -3. We have -3 again. And then we use our order of operations to simplify. So here we start with the parentheses. So we have 2, 1, -1. We multiply them together. So the first two we get 2. Then times -1, we would get -2. So our vertex point occurs at x is -3, y is -2. And then we could even start to picture, oh, it's going to go right there. So we could actually start sketching out our quadratic function. So let's do two more examples together with two different quadratic functions. So here we notice they're both written in intercept form. I know that this one on the right doesn't necessarily look like intercept form, but it actually really is, because this x by itself is really saying x plus 0. So even though it doesn't look like intercept form, it is. It's just an implied plus 0 in there. They didn't want to write the plus 0. So to start off each of these, let's find our x-intercepts. So the x-intercepts of this first one are the opposite of p and q. So p is -8, q is 2. So we have x-intercepts at 8, 0 and -2, 0. So those are my x-intercept points. Then I know that for my axis of symmetry, I can either draw a sketch of this graph or I can calculate it by using the average. So in this case, because these numbers are a little bit further apart, I'm simply going to use the average. So we take 8 plus -2, and then we're going to divide it by 2. So that becomes 6/2, which is 3. So now I know that my axis of symmetry is occurring at x equals 3. And if you were to graph these out and find the middle number, you would notice the exact same thing. So here's my axis of symmetry point, and we can see that it's right in the middle of our x-intercept points. Now lastly, we need to find our vertex. And remember, our vertex point uses the axis of symmetry x value because the vertex lies on the axis of symmetry. So we have an x value of 3, and we're going to use our equation to calculate our corresponding y value. Now I notice out in front here there's a negative, and I remember that that's really an implied -1. So we have -1, and then we have 3 minus 8 and 3 plus 2. So here we end up with y equals -1, -5, and 5. And then we get, well, the first two being multiplied is 5, then times 5, which is 25. So I can see that my vertex point is occurring at x is 3, y is 25. So I've now found my 3 key pieces of information. So now if I go over to the problem on the right and repeat this same thing, here I notice that P is 0 and Q is a -12. So I know that my x-intercept points occur at the opposite of those. Well, the opposite of 0 is just -0, which is silly because that's just 0. So we have one x-intercept at 0, 0, and we have another x-intercept at opposite of -12, so +12, 0. So those are my x-intercept points. And then remember, our axis of symmetry, we can find two ways. We can either sketch it out and look for the middle number between 0 and 12, or we can simply find the average. And remember, the average, we take 0 plus 12, so we take our two numbers, we add them together, and then divide by 2. So I'd have 12 over 2, which is 6. So my axis of symmetry is x is equal to 6. And that makes sense. That's right between 0 and 12. That would be the middle of those two intercepts. And then finally, we need to find our vertex. And again, we know that the x-coordinate of our vertex comes from our axis of symmetry. So we have 6 comma something. And we're going to use our equation here to help us find what that corresponding y value would be. So we have y is equal to 3 times 6. And then we have 6 minus 12. So we do parentheses first. So I have y equals 3. And I have 6 still. And I have -6. Then we multiply. 3 times 6 is 18. And then we take 18 times -6, which is a -108. So that's a pretty intense vertex there. We have x is 6 and y is -108.